Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh, all of you. This is Sir Adeel Fazlani, O-level mathematics teacher at the Gulshan campus C, Karachi, Pakistan. The topic that I have chosen for the revision is the volume and surface area, or we can say the mensuration, right? So we'll start with the volume and surface area, the first slide. And let me tell you the objectives. Yes, we are going to solve the problems involving volume and surface area of cylinders, prisms, and composite shapes. And yes, when it comes to the volume and surface area, students used to raise the question that how can I use what I know about the area, and how do you calculate the volume and the surface area, even the curved surface area. So you have already a basic concept which you already have learned in the previous years, from the previous years, right? So proceeding to the next slide. Right. When it comes to the cube, the cube is nothing but a 3D shape with 6 square or rectangular sides, a block. All right. And the rectangular prism, which is a polyhedron that has two parallel and congruent bases that are rectangles, a 3D solid with 6 rectangular faces. Similarly, we have different types: rectangular prism, triangular prism, and we have three-dimensional shapes. Yes, that is the cylinder, cube, the part of the three-dimensional, and volume, that is the measure of space occupied by a solid. Here, let me tell you one thing. So before going to proceed further, I would like to ask from you the types that you already have learned from the previous years, that is two-dimensional shapes, right? When it comes to the volume and surface area, you should know the basic concept of two-dimensional and three-dimensional. Yes or no?
Yes, sir.
Okay.
Yes, sir.
So, all right. So when it comes to two-dimensional and three-dimensional, can anyone tell me the types of two-dimensional shapes?
Circle, triangle, rectangle.
Got it.
Square.
All right. So when it comes to two-dimensional shapes, you have circle, yes, you have square, you have rectangle, you have trapezium, you have rhombus, you have parallelogram, right? There are other shapes, right? These are the well-known shapes, right? And those shapes who does not have a name, for example, a shape, if you just look into the shape and shape does not have a name. So do you know what do we name that particular shape in mathematics?
2D shape.
That is 2D shape, but yes, you can see on the screen. Let me give you an example. Just wait. All right. When it comes to shapes, when I'm just talking about shapes, so you have two things in your mind. Yes, you can say 2D and 3D. So what I asked from you, let's say you name this two, the example, the types you have named, that is square, rectangle, all right, triangle, and many more shapes, right? Okay. And when it comes to three-dimensional, you have cylinder, cone, we will say cuboid, and we have cube, many more shapes, right? Now, what I'm asking from you, see, square is, you are familiar with the square, that all dimensions are equal when it comes to the square. Am I audible to you?
Yes, sir.
Yes,
Yes,
sir.
sir.
This that this shape is this, like this particular shape is specific having a name. We are saying this is a square, and yes, this shape is having attributes that four dimensions, four sides equal, four angles are equal, four corners, four vertex, right? So asking from you, is there any specific name for this shape? Yes,
Irregular.
excellent. This shape is known as irregular shape. Irregular shape is, this is the well-known name in mathematics. This is irregular shape. Okay. Now, when it comes to irregular shape and you want to find out, uh, like for example, the volume of prism. Let's say if this is the shape, and if I'm going to ask from you, will you be able to see the screen? If this is a shape, what is the formula to find out the volume of this shape? Do you know the volume of prism?
Sir,
Prism.
length in length into width into height. You have to do that twice for the two rectangles.
Actually, you need to find out, if I'm asking from you that find out the volume of prism. So right now I'm just asking the random question. How do you find the volume of prism and what is the formula? Using length into breadth into width of twice. But actually the general formula for volume of prism is base area into height. Base area into height. Okay. And base area
सर
all
वो पिरामिड का
depends.
भी होता है ना?
It's a volume of prism. I'm talking about volume of prism right now. We'll talk about the pyramid. We will talk about the types of pyramid, yes. But right now I'm just talking about the volume of prism. Volume of prism, the general formula for volume of prism is base area into height. And base area always depends on two-dimensional shape. Okay. So base, whenever you use the formula, you just focus this thing that when the base area is there, so you always focus on two-dimensional from the shape. Now try to target the two-dimensional shape from this shape. Which shape is two-dimensional?
Rectangle.
No, we have irregular shape. You have found the shape which is two-dimensional, which is irregular. You see, this is irregular shape. Yes or no? Yes or no?
Yes, sir.
But how do you use the formula to find out the base area of this and the height? This is nothing but the height of prism. This is nothing but the height of prism. Height of prism. All right. And now let me tell you how do you make this shape regular. You need to extend the line, imaginary line to make a two rectangles. This is one rectangle. Am I audible to you? This is another
Yes.
rectangle. Okay. So if you're writing the base area, so you have to find out the area of area of figure 1, which is rectangle 1. All right, area of rectangle 1 plus area of rectangle 2. All right, this is how you find out the base area. Now this is going to multiply with the height of prism. And which thing indicates the height of prism? See, the area of cross section is this. Actually, this base area is also known as area of cross section. At times, we'll say this is nothing but the area of, we also use the keyword area of cross section. Area of cross section. Okay. Now, see, the base area is actually we have found from this irregular to regular shape. When such is regular, so we are naming that's area of rectangle 1, rectangle 2 times the height of prism. Height of prism is the height. You will find, see, you are actually applying a cross section here. When you apply cross section here like this, you will find this shape. Yes or no? Actually, you are just making a cross section like this. You're cutting a shape in such a way, you are applying cross section in such a way so that you are finding the identical shapes, identical 2D shapes, right? Like this. Yes or no?
Yes, sir.
So when you find a number of shapes like this, one time will come, this shape will become, the prism. And yes, the things which you are cross secting, the things which you are cutting, see, you are cross applying the cross section. Which thing is being cutted here? This line, the parallel lines, this line is also been cutted. This line is also cutted. This is the reflection of the height of prism. If you need to indicate, if you need to point out that which length is the height of prism, I must say the height of prism is a length which is been cutted altogether to make a two-dimensional shape. Like for example, if I'm going to ask from you, can you name this shape quickly?
Cylinder.
cylinder,
Cylinder.
Perfect. All right. And actually, as I told you, that this is also a three-dimensional shape. And again, the formula for finding out the volume of prism, this is also a prism, you can say. And what is the general formula for volume of prism? What was that? Volume of prism. What was the formula for volume of prism? Tell
Base
me.
area into height.
Yes. So I can write here base area. See, volume of prism is nothing but base area into height. Or base area, you can say, or you can say the area of cross section. Area of cross section into height or into length. So base area, I told you, depends on two-dimensional shape. Can you just track two-dimensional shape in this cylinder? Which shape is
सर वो
two-dimensional in this?
सिलेंडर के जो उस पेड़ जो होते हैं उसको काट देंगे.
Yes, first of all, just to let me know which thing is two-dimensional from this shape.
Circle.
circle,
Excellent. Excellent. So that means right now you have a regular shape available. So that's the reason you are naming easily that this is nothing but area of circle. Yes or no? Yes or no?
सर उसके सर वो जो सिलेंडर का जो रेक्टेंगल और स्क्वायर जो भी है उसको भी तो हम लोग 2D बना सकते हैं.
Just hold on. Just wait. See, two-dimensional shape. You need to find out the two-dimensional shape in such a way that is considered as an area of cross section. See, I cannot slice this cylinder like this. See, I cannot slice this cylinder like this. I cannot make a cross section like this vertically. All right, this is a wrong approach. But yes, when I'm going to apply cross section of this cylinder, I can find the shape that is 2D shape. When I apply again the cross section, I will find again the two-dimensional shape that is circle. If I'm going to apply again the cross section, I'll find two-dimensional shape. So one time will come, this will become a stack of the circles, and when you find a stack of circle, that this will become a cylinder. When you join all these the circles together will become a cylinder, right? So this is what I'm saying. See, the area of circle you have found, this is area of circle, it's okay, which is two-dimensional. And now height, what I told you, the height of prism is the height where you see the parallel lines being cut it together. See, what are the two parallel lines being cutted here? These are the lines. One line is this, second line is this. So this is the reflection of height of prism. Are you getting what I'm saying?
yes, sir.
Yes, sir.
All right. And I can write here H. So now volume of cylinder. If you remember the volume of cylinder, what is the formula you used to remember the formula in such a way? Pi r square h, pi r square h. So today, right now, even in this class, I have revealed the logic behind of saying pi r square h. See, this is area of circle. This what which is nothing pi r square. Yes or no? And this is the height. So we always
Yes.
say that volume of, yes, we always say that volume of cylinder is pi r square h. This is the reason behind of saying pi r square h. It's actually the area of cross section or base area into height behind this. Are you getting what I'm saying?
Yes.
Is it clear to you? Shall I proceed further?
Yes, sir.
Yes, sir.
All right. Ramin, can you just do one thing? Just take the picture of the slide and save it and then send it to me over the WhatsApp. Okay, taking the picture,
Wait, sir.
and also someone else can take a screenshot if you're using Android with full screen. Rami, sorry, Salid, you're using Android.
सर मैं कंप्यूटर पे हूँ.
Taken, Rami.
Yes, sir.
Okay. So back to the vocabulary words, right? So right now we are just continuing with the vocabulary that is triangular pyramid. We have a square pyramid, sphere, we have a cone, right? And yes, what is triangle pyramid? It is a polyhedron with a three-sided polygon for a base and a triangles. We'll discuss that triangle pyramid in upcoming slides as well, the square base pyramid and the sphere and all things. These are the only vocabulary keywords which gives you the concepts, actually the concept behind of three-dimensional sphere or cone or square pyramid or triangular base pyramid. Anyways, what is three-dimensional figure and what do they look like? All right. So yes, before going to proceed, and you already have learned the two-dimensional, which I have already talked about. We have a square, rectangles, parallelograms, and triangles, circles, and trapezoids, and trapezium-like. And these are the two-dimensional shapes, right? And you already have studied in previous years, right? And yes, if you're talking about particularly for three-dimensional shape, you have a sphere, have prism, you have cuboid, cube, cylinder, pyramid, and cone, right? So talk about the cube, rectangular prism, triangular prism, we have cylinder, and some additional three-dimensional shapes, that is triangle, pyramid, square base, sphere, and cone, right? And these are the examples and real life examples being quoted to you to connect this three-dimensional with the real life example. Let's look into the cubes. You'll find out the cubes, right? And the speakers similar to the cubes actually. And yes, you have prism, and we have different types, right? Okay, the cylinders. Right now, you just see uh, the real life example has been quoted here again. Sort of a tin has been reflected to you, the wheel. All right. Yes, we'll talk about the characteristics now. And yes, this cuboid, a three-dimensional shape with two parallel congruent polygons, bases, that is that when you join that two polygons, the congruent polygon bases, all right, when you connect both the polygon bases, which are congruent, you'll find the three-dimensional shapes, right? And what makes what, like a cylinder, we already have discussed, right? And yes, we have a square base pyramid, a rectangular base, a hexagon, pentagonal, or maybe a cone, a conical shapes, right? So right now we are proceeding with the formulas. Uh, right now I'm writing the cube formula, that is S cube, the side into side into side, or we can say L cube, right? People used to write L cube or S cube, side cube or length cube, all right? So the formula for volume of cube is L cube, right? And yes, formula for rectangular prism, See, be it rectangular prism, triangular prism, or cylinder. So general formula I already have talked about, that is base area into height. The general formula is actually the area of cross section, or you can say base area into height. Okay. Now, if you're going to apply the base area, which one is the base area? See, this part is actually the base area. And can you name this part? Only the thing which I'm just
Rectangle.
highlighting,
Rectangle.
rectangle. So what is the formula for area of rectangle?
Length into breadth.
All right. So can I also say length into width, Ramin? Can I also say length into width?
Yes, sir.
Which is nothing but your base area. Yes or no? And now see,
Yes.
uh, yes, now you see the way you have to go for the cross section. You're going to slice this prism in such a way so that you'll find the identical two-dimensional shape. See which thing I'm getting right now here. See, I'm slicing this. I'm applying a cross section here. So when I'm applying cross section, what I'm getting is two-dimensional. Two-dimensional shape which I'm getting is this. This is two-dimensional shape, a rectangle. You're getting rectangle. All right. So which is length into breadth, and the thing which you are which has been cutted, these are the pillars, the parallel lines. See, this line has been cross-sected, this line is cross-sected, this line is cross-sected. So this indicates that this is the height of prism. Got it?
Yes,
Yes,
sir.
sir.
All right. With the similar case study, uh, the volume of, let me raise this. Okay. Again, the triangular prism. I told you the base, if you just go with the base area into height or area of cross section, so base area is this part, okay, half base into height. And yes, you have a width left, which is the area. If I'm going to use the height here, it's okay. This is considered as a length. This is considered as a length as well, right? If I'm going to use W as a length, it's okay. Height as a length, it's okay. This is totally depending on your understanding that how you are perceiving, right? So what I'm saying is base area into height. Base area is nothing but the half base into height. This is your base area. Okay. Now apply the cross section. When you cut this shape in such a way so that you find a two-dimensional shape, so it's you have done with this. Now the things which has been cross-sected, the two things, the two parallel lines, this is the reflection of height of prism. All right. Or you can say width, no problem at all. Or length, no problem at all. Got it? Shall I proceed next? And this is the cylinder which I already have spoken to you. Shall I proceed to next class? Yes. All right. Find the volume of cube whose sides measure 3 inches. Who is going to answer me?
27 centimeter cube. 27-inch cube.
Excellent. Okay. Yes. Can you answer me this question quickly? Yes.
180-inch cube.
Excellent. Yes. Can you answer me?
61
72.
centimeter. No, 31. No, 36 centimeter cubes.
Yes, 36.
All right. Now, let me see who is going to answer first. Yes, what is the answer?
Sir, 150.79.
Are you sure? Anyone else?
Yes, sir, 150.8 RM.
सर पाई आर स्क्वायर एच लगाएंगे.
Yes, yes, perfect. And can anyone tell me what is the general formula for this volume of prism?
Base area into height.
All right. Is it your answer coming?
Yes,
Yes,
sir.
perfect. All right. Now, also calculate this quickly. You test your knowledge. See, you have understand the concept, the basic concept behind of all three-dimensional shapes. Now, right now, you're executing, you're applying whatever you have.
120-inch cube.
Okay, perfect. Right.
सर एक
Now,
मिनट सर उसके अंदर रेक्टेंगुलर प्रिज्म में आपने क्यूब क्यों डाला है वहाँ पे 128 क्यूब.
what is the unit of volume? What is
क्यूब.
the unit of volume? Yes. Whatever the unit is being used, whether inch, centimeter, millimeter, meter, so you always write cube in the volume, right? And use the area, the square in the area. Anyways, now can you do this question quickly?
385.
Okay.
अस्सलाम वालेकुम.
वालेकुम अस्सलाम. सॉरी बेटा आप मुझे
हाँ आपने
All right, just wait. We were on the slide. Just hold on. We have done with this cube, rectangle, triangle, cylinder, rectangular prism, and now triangular prism. Can you just find the answer of triangular prism? Yes, come on.
टू 270 feet cube.
That's excellent answer. Okay. Now, can you just find out the volume of cylinder?
339.29.
339.3 centimeter cube. Excellent. Okay. Can you quickly find out these four questions answers? Uh, all right. You do one thing. You just take this as a homework for a practice purpose, right? I'm going to proceed further, okay? Got it?
Okay, sir.
All right.
Okay.
These are the answers you can verify after finding out the question. Okay, now we'll connect with the real life examples right now. All right. Right now, a wooden block has a single hole drilled entirely through it. What is the volume of block? Round to the nearest hundred. Actually, this is the block, which is a rectangular prism and having a cylindrical hole, right? So to find the volume, you need to apply the technique that you need to subtract the volume of the cylinder from the volume of prism simply, right? So such type of questions, are very much expected in your CI exams as well. So it depends on the case study that maybe they definitely put a sphere in the cylinder and they'll ask the depth of when you remove the sphere from the cylinder, what is the required depth of the volume, or what is the leftover volume in the cylinder, or these are the questions that they used to ask and they used to form and to check your understanding related to the basic concepts of your composite shapes and three-dimensional shapes, right? So this is one of the example which I have presented to you, and let me proceed to the next. Yes, when you remove the particular what to say the block, okay, when you remove uh, the volume of the block, all right, when you remove the volume of cylinder from the cuboid, you will find the required volume. So for this, you need to find out the volume of this particular cuboid first. Yes, which is also known as block, and you remove the volume of cylinder simply. Got it? Shall I proceed to the next?
Yes, sir.
Yes, sir.
All right. Now again, these are the general questions which are being composed, right? And I already have told you that it depends on the situation. So you will be given the situation, and you'll be asked that two times, three times, or maybe four times of the sphere, or I mean, it's open question can be asked from you, but you should have a basic concept of these three-dimensional shapes actually. Got it? Likewise, if you just look into this question, a moving company has boxes of various sizes of packing, and the smallest box available has a dimension shown below. This is the smallest box dimension. You tell me, how do you find the larger box, which is three times as larger? Yes, what would be the strategy to find this? Can anyone share the thinking process behind this question? The logic building behind this solution?
Sir,
Yes.
sir, we multiply, yes, we multiply our answer with the dimensions with 3, and then we'll get the answer, or we can simply get the answer with these dimensions and multiply it by 3.
Yes, you can go with it. All right. So these are the such type of questions which I have quoted to you. See, this was the question, this is the question. For your understanding purpose, you can make it. This is another question, right? A real life, they can connect with their real life simply. At times they used to give a advanced thing, and then they'll ask from you, which requires a multiplication process here. Three times is multiplication process. At times you used to divide to find out the smaller size as well. This depends on the
Sir,
particular word problem, right?
sir,
Got it?
एक minute. Right now, I said that we can either multiply the dimensions as is and then multiply, or we can
You can
multipy it in
find
the
out.
end.
Yes, yes. You
But
can
the thing
find
is,
out. You're talking about this particular question, I think.
yes, I'm saying that I did it both ways, and both ways the answer is coming different. So what do we do?
No, 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 no. See, actually, you need to find out
Both
the
are
volume.
answer same answer.
Sorry. Can you repeat, please, what you're saying, Ramin? Salit? Salit, can you hear me?
Which time? Which time?
Okay. So, Raina, can you hear me?
Yes, sir.
Raina, actually, you need to find out the volume, which is whatever the volume is from this shape. All right. And after find out the volume, you need to multiply the three, which is three times larger than the volume of actually which is represented here. Got it? You need not to
Okay.
multiply with the sides, but you need to multiply with the volume actually, because they are
Okay.
talking about find the volume of the larger box. All right.
Okay. Yes.
Okay, they are particularly persistent for the volume. That's the actually solution. All right. When it comes to the summary, so we have talked about the cube, prism, triangular, rectangular, cylinder, and I hope that you got the concept and your concept is 100% clear. Yes or no? Is
Yes,
there
sir.
any ambiguity?
Yes, sir.
Shall I proceed next?
Yes, sir.
Okay. So now, uh, we have studied volume and it's time to move on surface area, another important concept which is dealing with the three-dimensional. And we have spoken about the volume. We have shared the tech. I have shared the technicalities. You have understand the basic concept behind of three-dimensional shapes and all. And you have understand the concept. You have applied. You have executed. You have tested. And now this is the time to go with the surface area. When you think about the word surface area, what comes to your mind? Yes. What do you say? Yes. Anyone? What is basically surface is? Surface
Area
area.
of the 2D shapes on the surface on an object.
All right. What does surface means? What is the basic meaning of surface? See, surface is actually the thing which is, if you let me give you the example. Let me give you the example of surface. Uh, for example, just hold on to say.
सर क्या हम ये कह सकते हैं कि किसी भी चीज की बाउंड्री
Mm, let me give you example. No, with boundary. No, no. Surface is. Let me give you example so that you'll get an idea. See, surface is like this. That if this is your cylinder, right? Got it. And if I'm going to ask from you the surface area, so I can give you example to make you make your concept clear of surface. The term surface, the word surface. Surface is actually the outer part. If let's say if you are going to wrap the particular tin or cylindrical shape with a thread, like if I'm going to wrapping this, all right, I'm wrapping and wrapping again and again, like I'm just wrapping completely. So what are the shapes that I have wrapped up till now? So if you're going to take the pieces of the wrapping area, you have wrapped this one shape, you have wrapped this one shape and this one shape, right or not? When you combine the three of the things, you will find the cylinder. Yes or no? If you combine
Yes.
these three things, you'll find the cylinder. So now what is the area of this shape? What is the area of this shape?
Pi r square.
All right. What is the area of this shape?
2 pi r.
2 pi r.
2 pi r
Right.
h. What is the
Yes,
area
yes.
of this shape?
Pi r square.
So if we are going to finalize the surface area of cylinder, so what is the final surface area of cylinder? Can anyone tell me?
सर
Yes.
सर आपने सेकंड वाले का कैसे बताया कि 2 pi r h है?
See, yes. See, 2 pi r h is the formula which is derived actually. See, this is 2 pi r h, the formula which is being derived. See, the formula for pi r square is actually derived. These are the derived formulas, right? So what I'm asking from you, when you add these three things, what is the final answer you are getting actually when it comes to surface area of cylinder in the most simplified form? Can you just tell me the simplified form of this formula?
Pi r 2 pi r square plus 2 pi r h.
The final answer is 2 pi r square plus 2 pi r h.
Yes.
Yes or no? Now, with a similar case study, if I'm going to ask from you the shape which I'm going to reflect, which I'm going to draw in front of you, can you name this shape quickly?
Cone.
Cone.
कौन?
Correct. And now, can you tell me what is the surface area of cone? What is the surface area of cone? The total surface area of the cone
सर
is actually
सर
based on,
वो
yes, yes.
सर मैं कह रही हूँ कि ये जो है वो पूरा तो एक तो सर्कल दिया हुआ है फिर उसका एक आर्क भी दिया हुआ है उसके साथ.
You're talking about which thing?
सर वो जो कोन का जो आर्क है
Yes.
जो नीचे सर्कल बन रहा है उसकी वजह से आर्क दिया हुआ है.
Now you see, when you're going to wrap this, all right, you are covering this part. Now this part which I'm covering right now is known as curved surface area. This is known as your curved surface area, all right, of cone. So you know what are the indications of curved surface area. See, when you remove the circle from the cone, you will find the curved surface area of cone. See, curved surface area is like this. You have removed, as if that you have removed the circle. This is nothing but the curved surface area. Now, This is again your nothing but the area of circle, which is pi r square. And we have a formula, particular formula for curved surface area. And the formula for curved surface area is actually pi r l. Pi r l. L is actually representing the slant height. This is the slant height. See, if this is the cone, if this is the cone, you have two heights. One height is the height of cone, which is falling from the vertex towards to the center of the two-dimensional shape. All right, center of the base. And one height is the slant height, which is always found diagonal. Are you getting what I'm saying?
सर अगर कोई इसको लेंथ कंसीडर करे तो
Uh, which one? Slant height?
यस सर
Yes, you can say slant height is considered as a length. Okay. Now, if this is a slant height and this is your height of cone, this is your height of cone. I can say this is your height of cone. So now you can say the length of cone, height of cone. See, when I'm talking about length, see, when I'm talking about height, width, breadth, these all are the length. All right. So, but now it depends on the concept that you are perceiving. Your concept has to be clear. Every length is not like a width. Every length is not like a slant height. So if you are just naming slant height as a length, so you have to understand and recognize this, the length, diagonal length is the slant height actually. The exact vertical length, which is which is from the vertex towards to the base of the circle, is the exactly height of cone, which carries a right angle triangle as well. I mean, which carries a right angle at the center. Got it? So this is how you name that length, right? We have a slant height, we have a height of cone. So now I was talking about actually the surface area of cone. Surface area of cone is actually pi r l plus which thing is added in it?
Pi r square.
Pi r square. This is the formula to find out the surface area of cone or total surface area. And when it comes to the curved surface area, you have this particular 2 pi rh. Your 2 pi rh also known as your curved surface area of cylinder. This is nothing but I can say CSA of cylinder. All right. And I told you what are the indication of curved surface area. I already have told you. Can anyone tell me what are the indications of curved surface area? I told you, no, when you remove the circle, you see, I'm just removing the circle from the top and from the bottom. I left with this shape. So this is known as your curved surface area of cylinder. Yes or no?
यस सर
Yes,
All
sir.
right. Okay. So just hold on. Let me write the date. And let me put my side. Okay. Ramin, can you just take the screenshot of this and send it to me over the WhatsApp? Taken?
यस सर
Okay. Now, see, when it comes to the surface area, what comes in your mind? This was a question. Then I reflected the examples. I have shared the examples to make you more strong in this area. Now, when you think about the word surface area, what comes in your mind? Now your concept is clear of surface area? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, proceed to surface area nets, right? So when thinking about the surface area, we need to able to break down the three-dimensional solid by its faces. Like this is the three-dimensional solid, all right, three-dimensional shape. When it comes to net of this shape, so you'll find how many, see how many rectangles do we have? We how many squares do we have? Because when it comes to cube, we have a squares because cube is all L cube, all same. S cube, L cube, the volume of cube is L cube. So that is the reason you will find out the squares. When it comes to cuboid, you'll find out the rectangles in the net of that particular diagram. So right now I'm talking about the cube. This is the net of the cube, right? And when you open this cubicle box, you'll find the net like this. It is in front of you. Can you see the net? Will you be able to see the net
Yes,
of
sir.
cube? All right. So you find the six squares actually. All right. And yes, let me proceed to next. Yes. Now see the difference. You'll find here again. I have quoted the cuboid. This is cube and this is cuboid. And yes, we can say this is triangular based pyramid, prism. Triangular based prism, right? And these are the nets actually. Uh, when it comes to the three-dimensional shapes, so these are the net of three-dimensional shapes, right? Got it? Yes or no? All right. So now, very important formulas. When it comes to cube, so what is the formula for cube? Surface area of cube is 6L square. And when it comes to the rectangular prism, what is the surface area? The surface area of rectangular prism is 2 times length width plus 2 times length height and plus 2 times height and width. All right, these are the basic formulas that you already have learned in previous years. You already have learned.
सर एक मिनट पीछे कीजिएगा.
Yes, yes.
Thank you, sir.
All right. Now, when it comes to triangular prism, so you have a triangular prism that, yes, two times of half base into height, okay? And you have again length and width with 1, 2, and 3. Got it? And with the similar case study with the cylinder, 2 pi r square plus 2 pi r h. And this surface area always, the surface area of cylinder contains the curved surface area. This is curved surface area is inclusive in this surface area. So when it comes to total surface area of cylinder, or at times they use the keyword total surface area, and at times they used to say that surface area of cylinder. So both is having a same concept that when it comes to total surface area, when it comes to surface area, actually you need to get your concept clear of the surface, the keyword surface that I talked about, and I have shared the examples to you, and your concept is now alhamdulillah clear, right? Now, surface area of cube is 6 square, 6L square. You're applying simply the formula. All right, I have revealed the formulas. This is the time to execute it. So we're just running short of time. So I'm just proceeding to the next examples, right? This is the formula for finding out the surface area with the dimensions given, and you need to apply it. Yes, I'm just fast forwarding right now because when we are just running short of time and we have to do part two of volume and surface area, we can say the mensuration as well. All right, find a surface area of triangular prism. You'll apply the formula simply with the dimensions. You'll find the desired result, right? And the formula to find out the surface area, apply the formula and find out the answer. All right. Again, this is the problem solving. Okay. And it depends on your comprehension and the concept that if your once your concept is clear, then you'll be able to find out the answer, right? See, this time you are asked to find out the surface area. So when it comes to surface area, it is better for you to just recognize, you just understand and draw the net of that particular shape so that you'll find out the area and the dimensions. All right. This is the only trick which helps you to find out the surface area. And this is another example which is given with respect to the dimensions, and you have found the answer. And actually you are applying the same scenario of surface area. Now, what do you know about the sectors? Yes. Can you tell me what do you know about the sectors? Yes, class. Am I audible to you? Class, am I audible to you?
Yes, sir.
Okay. What do you know about the sectors? See, actually, the sector is been taken from the circle. See, this is the circle.
सर वो जैसी सर्कल होता है उसके अंदर से एक पार्ट आप निकाल लेते हो उसको सेक्टर कहते हैं.
Like, see, all right. Yes, to Ms. Ali. This is what we say the sector is. Apart from a circle, all right. So you have actually you have two types when it comes to the sectors. We can say minor and major. All right. You have minor sector and you have major sector. All right. Your minor sector is this. All right. And your major sector is just like a shape of a Pac-Man, like this. This. All right. So you have a minor and major sector. And again, when it comes to minor and major, you have two categories. You have minor area of minor sector. You will find area of minor sector, area of minor sector, and you'll find out the arc length of minor sector. Okay. And again, one more category you have, that is perimeter of minor sector. All right. So basically, this minor sector is being categorized with this perimeter. This is perimeter. All right. This is perimeter. And this is your area. This is your area. And this is your arc length. Okay. So we have same three categories, like we have perimeter of major sector, perimeter of major sector. You have area of major sector. You have area of major sector, I can say, and you have arc length of major sector. Perimeter of major sector, area of major sector, arc length of major sector. Are you getting? So these
Yes,
are the
sir.
categories. Actually, these are the categories which plays very important role uh, when it comes to the sectors, right? So now let me tell you. Let's say if we are going to talk about, if you're going to talk about the perimeter of sector, all right, perimeter of sector, so minor sector. So what is the formula? First of all, you need to understand the formula for area of minor sector. Area of minor sector. Area of minor sector is nothing but theta upon 360 times pi r square. Remember one thing, uh, trick to remember the formula is that as you know the area of circle, area of circle, what is the formula of area of circle? You tell me.
Pi r square.
Pi r square.
Yes, area of circle is actually pi r square, which you already have in your mind. So when it, since I told you that this is the part of a circle, sector is a part of circle. So that means this sector is belonging to the family of circle. The parent of sector is circle actually. So when the parent is having a name pi r square, all right. So definitely the sector is having a pi r square. All right. When the parent is pi r square, so why not child is pi r square? All right. If the, for example, the surname of someone's father is, let's say someone father is, surname is Qureshi, so definitely is having the surname of his children's Qureshi. So if the parent is area of circle, the parent is sir pi r square. If parent is pi r square, so the part is also a pi r square. This is the common thing. Got it? Now, when it comes to the areas, you will use pi r square, but this is the additional part that you need to remember, that is the sector. Actually, you are just taking a part from a circle that is, let's say, this is the part. Okay, when you are just taking this part, the certain theta is being used only out of complete region. What is the complete degree of circle? What is the complete degree of circle?
360.
So that is the
360.
reason. Yes, that is the reason we are writing here theta, which is a part, the theta over 360 means upon total degrees, that is 360. That is the reason we used to write theta upon 360. Now, with a similar case study, if you're talking about area of, sorry, arc length of minor sector, arc length of minor sector. So again, when it comes to length, this is very, very important. You will find again, you're talking about this, the minor sector is remains same minor sector. All right. But this time, you know what I can use here? Can you tell me? When it comes to area, we will use pi r square, keeping in view area of circle. Can you tell me when it comes to length, what can I use here? And how do you connect this length with circle? Actually, this length is connected with the circumference of a circle. If you remember, what is the formula for circumference of a circle?
2 pi r.
Yes. Now this is quite easy for you. Your circumference of a circle. All right. Circumference of a circle is nothing but 2 pi r. So I can use here formula for arc length of minor sector is theta upon 360 times 2 pi r, because I'm using here length. So length is actually is sort of a boundary. We can say a perimeter, a length or circumference boundary. A part has been taken, a sector, minor sector has been taken. So it's theta upon 360. And since it's a length and the family name is 2 pi r when it comes to length, when it comes to the area, the family name is pi r square, you're writing pi r square here. All right, when it comes to length, the family name of, the length is 2 pi r. Got it? Is it clear or not? Now, perimeter of minor sector, right? Perimeter of minor sector. So let me write perimeter of minor sector. Actually, perimeter of minor sector is, what is the general formula for perimeter? Can anyone tell me? What is the general formula for perimeter?
Sum of
Sum
all
of all
sides.
sides.
Excellent. The general formula for perimeter is sum of all sides. 100% correct. So right now, you're talking about perimeter of minor sector. So perimeter of minor sector is sum of all sides, you're saying. See, try to track the figure out this minor sector. What you have in your hand. This is known as what in mathematics? Yes.
Angle.
No, this is your theta. It's okay. I'm talking about this length. This length.
Radius.
Yes, this is radius. This is also radius. And this length is known as what?
Circumference. Pi r
This
square.
is this length, this particular length is known as arc length. All
Okay.
right. So your perimeter is actually, when you break this minor sector, you will find this length. You will find this length and you will find this length. All right. So you have this R plus, you have this R plus, you have this AL. Yes or no? So now the formula of perimeter of minor sector is now quite easy for you to understand. Is actually 2R plus arc length. Is nothing but 2R plus arc length.
Arc length.
Yes or no? Is it now easy
Yes,
for
sir.
you to understand? Yes. Now when you open this arc length, you will find arc length. The formula for arc length is this. All right. When you open the arc length further, you will find out this formula along with 2r to find out the perimeter of minor sector. Got it? Yes or no? Yes or no?
Yes, sir.
All right.
Yes, sir.
Okay. All right. Just hold on. Just wait. All right. So let me talk about uh, the major sector. All right. Can you see the screen?
No, sir.
Now, can you see the screen?
Yes, sir.
Okay. Now just see. I was talking about now what you have to understand is a major sector, right? Now let me talk about major sector. I have already spoken about arc length, area of minor sector, and perimeter of minor sector. And now there is a turn for major sector. When it comes to the major sector, let me draw this. This is the major sector. Got it? Now again, this major sector is the part taken from circle. Yes or no? A part which is taken from a circle. So I can say the area of major sector. Area of major sector is nothing but 360 minus theta upon 360 times, since it's area, so you tell me it's a part of a circle. So what comes here? What can I
Pi r
write here?
square.
Excellent. Excellent. So what is the change in the formula for major sector is 360 minus theta over 360. And actually this is the m- major sector. All right. So you are removing the minor one arc. So the minor one angle actually to find out the major sector. That is the reason you are writing 360 minus theta upon 360 into pi r square. Now, if I'm talking about the arc length of major sector, can you tell me what is the formula for arc length of major sector? Keeping in view the area of major sector. Yes, anyone? Any idea?
सर ये वाला तो सेम ही रहेगा ना 360 माइनस थीटा अपॉन
Yes,
360.
excellent, Miss Alit. Because we are working on major sector. So the change only comes in the last part, then the last thing that is this. You know what comes here? What will
2
come
pi
here?
r.
2
pi
pi
r.
r. Yes, because you have noticed one thing. once your concept is clear of length, once this concept is clear that actually these are the things being taken from a circle, the parent is actually a circle. When it comes to the pi r square, so you will use pi r square and minor sector in all cases. All right. Now, if it is be it pi r square, see, be it minor sector or major sector, you will use in both cases pi r square. So only difference in major and minor is theta upon 360 in minor, and the major is 360 minus theta upon 360. And lengthwise is both the same case study with the lengthwise. Right. So this is arc length of major sector. Now, can you tell me how to find out the perimeter of major sector? Yes. How to find out perimeter of major sector?
Yeah, this will also remain the same.
सर ये सेमी सर्कल होगा क्या?
Perimeter of major sector. Perimeter of major sector comprises of what? You tell me.
Two radius and one big arc length.
Yes. Big arc length is known as 2r plus
Length
2r
2r
plus
plus L.
major arc length. Major. You say major arc length. Got it? Two R is, this is your R, this is your R, and this is nothing but major arc length. Got it? Yes or no? Your concept is through with the, your concept is clear with the major arc length? Yes or no?
Yes, sir.
Okay. All right. So apart from volume and surface area and mensuration, I guess most of the things we have covered. And have you done with the curved surface area of hemisphere? Have you done the curved surface area of hemisphere or sphere?
No, sir.
Okay, just this is the only, I think, part which is we forgot to cover with. Just hold on. Just wait a second, please.
So what about pyramids?
Yes, the types, pyramids types, and the sphere is left, right? Just wait. Yes. Will you be able to see the screen? See, if I'm talking about which shape is this? This is nothing but a square based pyramid. This is square based pyramid. Yes or no? And which shape is this? Which shape is this? Can anyone name this shape?
Pyramid.
No. This is also known as rectangular based pyramid. All right. And this is cone. This is cone. And if I'm talking about triangular based pyramid, all right, you'll find a shape like this. triangular base pyramid. Now, this is, let me write here, triangular based pyramid. All right. So the general formula for pyramid is what? 1 upon 3 base area. 1 upon 3 base area into height. The general formula for volume of pyramid is 1 upon 3 volume of pyramid. Let me write here. Will you be able to see on the screen? That is 1 upon 3 into base area into height of pyramid. Okay. Now, height again, your base area is actually depending on two-dimensional shape from the pyramid. See, now if you just look into the square based is 1 upon 3. Can you tell me what comes in base area?
6L square.
It's L square. Excellent. Now, can you tell me what comes in base area in the place of base area when it comes to rectangular base? Come on, quickly.
Length into
Yes,
width.
length into
Width.
width. Okay. And we have a height of pyramid. Now, can you just tell me the volume of, this is volume of square based. This is volume of square based, volume of rectangular based. This is volume of triangular based. Now, volume of triangular base, come on. What comes in the bracket?
1 upon 2 base into height.
Half base into height. Excellent. Okay. And now, if you are talking about volume of cone, 1 upon 3, what is base? What is base? Volume of cone,
Circle.
circle.
Pi r
What is
square.
सर
IR? Yes.
सर ये मुझे समझ नहीं आया.
See what I'm saying? The general formula for volume of pyramid is 1 upon 3, 1 upon 3 base area into height. Okay. So once it's 1 upon 3 into base area into height, you need to identify the base area. Like for example, we have a different types of pyramid. Miss Ali, try to understand. See, this is the square base pyramid. So this is the identification of square based pyramid. So the base area is a square. This is the rectangular base pyramid. The base area is rectangle. Now you need to target the base area. Since 1 upon 3 and height of pyramid is the common thing. Height of pyramid is the height which is coming from the vertex. This is your vertex. Okay. From your vertex towards to the center of the base. Center of the base. This is your height of, this is your height of actually pyramid. Okay. The height of pyramid. Now what I'm saying, you need to focus on 1 upon 3 base area into height. Base area is depending on two-dimensional actually. And two-dimensional is your square. Two-dimensional, what, which thing is two-dimensional in this shape? Miss Alit?
पहले वाले में स्क्वायर है, सेकंड वाले में रेक्टेंगल है.
A rectangle, right? You can use a formula for rectangle. And which one is the base area and the cone?
सर्कल.
Circle. I hope that you got my point now, Miss Ali.
यस.
Yes, excellent. Got it. Now, proceeding to, we have done with the types of pyramid. Yes. And now, let me tell you the concept of sphere. When you talk about the sphere, so we have volume of a sphere, we have surface area of a sphere. All right. So your volume of a sphere is 4 upon 3 pi r cube. All right. When you're talking about surface area of a sphere, so the see, sphere is just like you can find the real life example. You can say the football. Football is a great example for sphere. So volume of a sphere is 4.3 pi r cube, and the surface area of sphere is 4 pi r square. All right. And the great example is actually the football. If you're talking about hemisphere, hemisphere is a half. Hemi is the half of sphere. If you talk about hemisphere, so you have again the categories. You have volume and you have a surface area. All right. And in fact, you have a curved surface area. All right. So your volume is half, half of sphere. When you say the half of 4 upon 3, so half of 4 upon 3 is 2 upon 3 actually. And the rest of the thing will remain same. All right. And your surface area, since the surface area of a sphere is 4 pi r square, so the surface area of hemisphere is now 2 pi r square, since it's the half of the surface area of a sphere, and the curved surface area of hemisphere. See, if I'm going to draw this is hemisphere. So if you're talking about hemisphere curved surface area, did you remember what I told you? What was the trick that I told you how to find out the curved surface area and what is the technique? What was the technique of curved surface area? I told you twice a time, if you remember.
बोला था थ्रेड करके करने वाला.
That is the surface area, but curved surface area, when you remove what? When you remove circle, when you remove circle from the object, it will become the curved surface area. And now the curved surface area for hemisphere is actually 2 pi r square. Okay. Now, if I'm going to, yes, there is one more thing in hemisphere, which is total surface area. Total surface area. You tell me your total surface area of hemisphere comprises of what? Look into total surface area. Your total surface area comprises of your curved surface area and your this one area. Okay. So your curved surface area is what? 2 pi r square. And your circle is pi r square. Now you tell me, if you add both of the things, what is the final formula for total surface area then? Yes. When you add 2 pi r square plus pi r square, what is the final answer? Will become, it will become 3 pi r square. Yes or no? It will become 3 pi r square. Class, am I audible to you? Yes.
sir.
Okay. Sorry, I'm writing cube here instead of square. Just hold on. It's 3 pi r square. When you add 2 pi r square and plus pi r square, it will become 3 pi r square. So I already told you the concept of curved surface area. See, when you are removing the top circle and bottom circle, this will become CSA of cylinder. Yes or no? This will become CSA of cylinder. All right. And if you're talking about curved surface area of cone, you're removing again the circle. This will become CSA of what? CSA of cone. You remember this? Now, in this category, I told you when you are removing the circle once again, this will become CSA of what? CSA of what? Tell me. Yes, class.
Sphere.
Hemisphere. CSA of hemisphere. Got it? And CSA of cylinder is already have declared the formula is nothing to pi r h. And you can say CSA of cone is 2 pi r l. Is it 2 pi r l or pi r l? Yes?
Pi RL.
Yes, it's pi r l. It's not 2 pi r l, it's pi r l. It's pi r l. What is L? What does L means?
Length.
Which length?
The vertical length of the curved surface.
No, it's not vertical. It's not vertical. There is a specific name.
Perpendicular.
No, 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 no. There is a specific name which I have explained to you earlier when I was explaining you the curved surface area of cone. What was that? That was slant height.
Height of
Slant height. Did you remember? I told you this L is nothing but slant height, which is always found diagonal. Did I say this thing to you? This is nothing but
yes.
slant height. So these are the things which you should know while doing, sphere, hemisphere, cylinder, cone, and the curved surface area. This is the, complete, volume and surface area and the mensuration. Got it? Is there any question from this topic that you need to ask? Yes.
No, sir.
All right. All clear?
Yes, sir.
All right. So right now, um, I'm going to sign off for the session, revision workshop,
Sir.
and the volume and surface area and mensuration.
Sir.
And then I'll
Sir.
continue with that topic. Uh, hold on, hold on.